All right, so when I introduced radians, I said we have something real special in the next video. This is that video. Okay, so let's look at arc length. Okay, and here's the big surprise. It didn't have to be a surprise. I could have just told it to you in the last video, but it's always good in life to have something to look forward to. The big surprise is that 1 radian is 1 radius of arc length. That might not look that exciting or might be a little confusing, might not make sense, but here's what I mean, right? So if I look at 1 radian in a circle, Jason, you can think, right? There's a whole circle. Well, that actually looked kind of good. Then this thing right here, whatever this distance is the same as that distance. These are the same distance. These are the same lengths. If this is 1 radian. If the angle is 1 radian. So again, similarly, right? If we had, hold on, I'm not going to be able to do this again. Wish me luck. Here I go. All right, yeah, that's not as good. If we had 2 radians look something like this. I'm closer to this. We had 2 radians, right? Then this distance right here, this is 1 radius. And this distance up here is twice. That's the whole point of a radian. The whole point of a radian is 1 radian is an arc length of 1 radius. Okay? So if we do some examples with this, example 3, find the arc length S. In this first example, we have an angle of pi over 4, a radius of 2 meters. Question is, what is this S? Well, if it was 1 radian long, if the angle was 1 radian, then it'd be 2. If the angle was 2 radians, it'd be 2 of these, or 4, and so on. But we have pi over 4 radians. So S is pi over 4 radians, the angle, times how long the radius actually is. All right, so this right here is going to be our theta, and this is going to be our radius. And that's all there is to this whole problem. Just simplify. The 2 cancels. We're just going to get pi over 2 meters. And you could approximate this if you'd like as well. Sometimes I'll ask for an exact answer. Sometimes I'll ask for an approximate answer, and this is what I mean. Exact means don't round. Include it in terms of pi. All right, so that's part A. And also do part B. Let's actually do something that's 2 radians long. Again, if there's no units, we assume it's radians. This is not 2 degrees, 2 radians. And let's say our radius is 3 centimeters. Well, then S is just, well, how many radians is the angle and how long is each radius? So S is just 6 centimeters. And this is one of the reasons why radians are nice. Because if we didn't have radians, right, what if I asked you to do like, I don't know, 92 degrees. And this is 2 centimeters or something. I ask you to find S. If it was degrees, we'd either have to convert it, and you don't have to write this problem down, but we'd either have to convert it to radians or figure out what portion of the circle is this. Okay, and your calculations would be, well, what percent of the circle are we? We're 92 out of 360. That's what percent of the circle we are. What's the circumference of the whole circle? And we'll take that percent of the circumference of the whole circle, which is 2 pi times r, which is 2. And notice that this is almost exactly the same as the other one. The difference is that with this right here, we're converting it into radians. So really are just converting it to radians if we solve this problem with degrees. And that may or may not come up. I don't actually remember off the top of my head. Let's do one more example. One more example for this video. All right, find the length of an arc of a circle. There's a lot of ofs here, stay tuned, of diameter 14 meters, pretty big circle, subtended by the central angle of 5 pi over 6. So this might look like a bit of an intimidating problem, but it's just a lot of words to mean exactly what we were doing before. All this means, and this is the wording the book uses, all this means is this. Angle is 5 pi over 6. What is S? The well, it gives us the diameter. So convert that diameter to the radius. That's all those words mean. How many ofs do we have? Find the length of an arc, of a circle, of a diameter. 3 ofs in a row. Goodness. That's all they mean right here. Okay. So again, this S, we have 5 pi over 6 radians. How much is a radian? A radian is 7 meters of arc length. Radians times radiuses, radii. That's all you have to do. That's going to be 35 pi over 6 is the exact answer. You can also approximate right here. Get an approximate answer. You could even use, maybe you wanted to use Desmos. Hold on, this is better planned in my head. Maybe you wanted to use the website Desmos. Hey, there it is. And you could say, okay, Desmos, what is 35 pi? What was our answer? 35 pi over 6. And then you'd say 35 pi, hit the fraction bar, the forward slash right next to shift. 35 pi over 6 is approximately this. All right. So you just copy that down, and that would give you your approximate answer. All right. That's about 18.3260. And make sure to have our units, which are in meters. And again, this right here is what's known as the approximate answer, as opposed to this, which is the exact. Sometimes I'll ask for one, sometimes I'll ask for others. You have the tools necessary to survive in a land where trigonometry... No, you don't. You'd die. You have the tools to survive in a land where this section is life or death. But by the end of the quarter, you'll have tools to survive in a land where trigonometry is life or death. Good luck. Let me know if you have questions.